Now that you've plotted all of your points on your car crash, what is it that you need to do to get all of the data and graphs and everything else that you need to complete this project? First thing, once you've plotted all the points, is to make sure that you've done a calibration stick. If you have not done a calibration stick at some point in the video, you need to make sure to do that. Remember that the Institute of Highway Safety sets this dot-to-dot distance on these cars as 24 inches. That will then give you a correct scale on all of your graphs. Once you've done that, open your graphs. Here's my graph of position versus time. I need to make a copy of this, print this out, to turn in with my lab. To do that, I'm going to right-click. When I right-click, it gives me this list of options. Towards the bottom is print. I'll press print. It will give me an option to print. You can print it to a printer, or one of the other options, if you're not connected to a printer, is to print to a PDF. If you save it to a PDF file, you can then print it at a later date. So if I print here, I've got one option as to print to one of my printers, or I could print to a PDF. It'll give me the option to save the file. And I can go through the process of saving the file as a PDF. The other thing I need to do is do the same thing with a velocity versus time graph. So I'll pull up my velocity versus time graph. To do that, I click on this X on the y-axis, the vertical axis, and you see you have a list of many different choices, one of which is Vx, x component velocity. I'll also want to right-click and print this. Once I've done that printing, I want to go back and find the slopes at 3 key points. So I will select back to my position graph. I'm going to right-click and select a section of the graph and hit Analyze. This will bring up the Analyze window. You see right now all of the points are highlighted. What I'm going to do is select a section of the graph, go to Analyze, hit Curve Fit, and that will give me a best fit line, the faint purple line you can see right here, for that section. And I know the slope would then be 1.425 e to the third, or times 10 to the third, so equivalent to 1,425 inches per second as the velocity at that point. Remember, you are in inches with 24 inches, so make sure you do that in inches per second. If I switch over and do this section, so deselect your previous point, select this section of the graph, I can get the slope here, 2.475 times 10 to the second. So the same as 247.5 inches per second after the collision. I also want to do the same thing for get a slope for the velocity versus time graph. So I'm going to close my Analyze window. I'm going to switch to a velocity versus time graph. I'm going to go back to Analyze. Now the problem here is you'll see, because you did the position time and now the velocity time, is going to put them on the same scale. So I want to take the position time graph out and select the section that I want of my velocity versus time. Well, for velocity versus time, I want to look at the section where it was changing velocity. So it was relatively consistent here. It was relatively consistent here. My change of velocity is this section here. So my acceleration would be 5.150 times 10 to the fourth, or 51,500 inches per second squared. So those are the 3 data pieces you need to pull out to put into that chart. The slope before the collision of the position versus time, which is your velocity, the slope after the collision, which is your velocity, and the slope of your velocity versus time graph during the collision, which will give you your acceleration of your collision. You'll do that for the car, the crash dummy, the second car, the second crash dummy. You should have 8 total graphs and then that data. If you have any questions with this, please ask in class or email me to get assistance.